Welcome back to the Introduction to Linked Data and MongoDB using Python course. In the last lesson, we looked a bit at representing terminology using the RDFS and OWL namespaces. And today, we'll be looking at knowledge graph search using SPARQL. So let's find out what kind of information there is on laureates. So last time we dumped out our enriched metadata set to disk, and here I'm just going to open it back up. And we are going to prepare a basic SPARQL query. So SPARQL is a recursive acronym. It stands for SPARQL Protocol and RDF Query Language. So it's not only a query language, but also a protocol for sending messages to the graph and getting responses back, that sort of thing. So from RDFlib, we're going to have a prepared query. And this is what SPARQL, a basic SPARQL query looks like, maybe similar to SQL if you've seen that. So we have a select statement, and we're going to return a bunch of rows in a table, and these are the elements of each row, subject, predicate, and object, and here's where we do some pattern matching on our triples, where that S, that subject that we're getting back, should be a Nobel laureate. And A is a nice SPARQL shorthand for RDF type. It's kind of a built-in, so you can just say A. And so that's one statement ending with a period, and also, it unifies on this variable S. That's the subject of this statement. S, RDF type Nobel laureate, and it gets all of the statements for which that subject is the subject, unifying that variable, and we will bind predicate and object for each of those triples and return all of them. And we've sort of initialized a namespace within this query where Nobel corresponds to that, and so that's how we're able to expand this prefix into its appropriate URL. This compact URI into its own thing. So when we run that, we've just prepared the query, and so now we can execute that query against the graph, queue against the graph, and take the first 100 rows and print those. So here we have a bunch of statements in the graph where the subject is a laureate. So here we have laureate 78 of type laureate and all of the other statements about that laureate. So we're essentially getting all of the statements in the graph where the subject is a laureate. Okay, and we just get several of those rows. I see that there's this dbpedia ontology prefix, so let's go ahead and prepare for that. Let's create a namespace for this dbpedia ontology, and I'm just going to write out this prepare query function that given a query string will sort of insert this thing for us. This initialize these namespaces up top, so we can just sort of pass the RDF's the SPARQL query to this prep queue function, and be a little bit simpler. I'm also going to provide a bunch of other namespace manager bindings. A lot of these we had before, but because I just reinitialized the graph, I'm going to make sure that we have a lot of these bindings ready. So we'll have the laureate namespace, country, city, university, dbpedia property, dbpedia ontology, Nobel, and friend of a friend. And so this allows us to have, when we list out triples, to have things like RDF colon, but for these other namespaces. So we have a shorter representation of the full URLs. So I'm binding those namespaces, and for this lesson I'd like to concentrate on a specific question. So I'm making a markdown cell here in the Jupyter Notebook. What fraction of laureates are affiliated with an institution in a country that is not in their country of birth? That is not their country of birth. So this is what that query is going to look like, or one of the queries to answer it. So we have our select line, but let's figure out what exactly. So what we want here is we want to identify these laureate resources, and we want to count them and present that as n laureates. And so what are the laureates that we want? Well, we want, okay, we're going to call it laureate, but SPARQL doesn't know what that means. But if we say, okay, this is what we're going to call the variable where there's triple matching on, this is a Nobel laureate, okay, I'm going to remember that variable and call that laureate. And then I want to find laureates such that they're also triples, where this is also the subject, and it has a DBpedia ontology birthplace predicate of something, and make sure that thing is a country in the graph. So when I go ahead and do this query, this is what I see. So there are 1,052 laureates, which laureate records, which have a record in their laureate record of having a birthplace in a country. So maybe some laureates don't have a birthplace recorded, or they might have a city recorded, but not a country. And so we're having kind of filtering our data set a little bit, right? So not all maybe necessarily have that, but we're confirming that there. And that SPARQL query does. So building that up a little bit, what I'm doing now is I'm counting the number of laureates where, okay, laureate again is a laureate, where the laureate has a statement in the graph connecting it with something else via this affiliation predicate. We're going to call that object an institution, and this institution should have another association in the graph as being in some country, in some other thing that's a country. So let's look at that. So this is the number of laureates that have affiliations with institutions for which the country is recorded. So there are 785 of those. Okay. Building up this query now, we want to count the number of laureates, where again we bind to this laureate variable. So we're doing pattern matching across all of our triples, where this laureate has a birthplace recorded in some country, the birth country, and the laureate also has an affiliation statement in the graph. Not all laureates necessarily have an affiliation statement in the graph, where again it's affiliated with some country. So this is sort of the number of laureates that can apply to our query. So there are 889 which have a recorded country of birthplace that is a country, and an affiliation that also has a country record. Next query, we're going to count the number of laureates where, again, calling it a laureate, it matches this statement, matches the subjects of this statement, where the laureate has a birth country, we're going to call it B country. The laureate has an affiliation with some institution that has a country that we're going to call I country, institution country. And we're going to filter for the cases where the B country and the I country are the same term, are the same RDF term, the same URL. And so 525. So the result of this is, okay, how many laureates have an affiliation at an institution that is in the same country as their country of birth? It's 525. And so now I'm going to do a very similar query as the above, but I'm going to filter for where there's no same term. So these are counting the number of laureates for which they are not affiliated with any institution that is in their country of birth. So that's 364. So 364 plus 525 should be 889. We get that? Great. And just to find this little helper function as a percentage. So just saying, how many, the percentage 364 of 889 using this Python string formatting. So there we go. So a little over 40% of our laureates that have a country of birth recorded and an affiliation recorded with a country are not affiliated with an institution in a country in which they were born. Cool. Let's see. Exploring SPARQL a little more, we can do these things like include prefix declarations directly in the statement. So I'm just going to go ahead and print this out so that we see what it's doing. So we can prefix, Nobel being this, DBO being this, and we can do all this stuff that we did before. And so this works directly in the SPARQL language itself. It doesn't require the init namespace thing that we had above. We can kind of directly pass it to the query in the SPARQL language, but it's convenient to do it through the rdflib mechanism. And we can also do aggregations. So for example, if I get all of these, so this should give that same query as before, where we're actually going to get the count of laureates that match this, as well as the institution country and birth country, and we're going to group by this compound key of institution country and birth country, and we're going to order by descending number of laureates and just limit to the top 5. So I'm going to go ahead and prepare that query as listed above, and I'm going to issue it. So we can see that that there were the most laureates that satisfy this query for a given unique institution country birth country location is 21. So there are 21 laureates who were born in Germany and who do not have an affiliation with an institution in Germany. Rather, it looks like all of them had an affiliation with a U.S. institution. The second highest is immigration, you might say, from United Kingdom to USA, Canada to USA, Poland to Germany, and Russia to USSR. So it's not necessarily immigration per se, but it's just that there's a different country of affiliation. Okay, so I hope this was helpful. Just dipping your toes into how to use the SPARQL protocol in RDF query language in order to do graph search using pattern matching across these triples, using this triple pattern thing, and having syntax that's reminiscent of SQL, being able to project out rows of quantities using some simple functions and aggregations. So this is all, and also inline filter functions with some, again, built-in functions to SPARQL. So this only touched the surface of it, but hopefully this is helpful. If you have a bunch of triples and you can load them into RDFlib, you can do graph search of your knowledge graph just using the SPARQL query language, and that's sort of, there's a built-in driver for that, for the built-in in-memory store for RDFlib. In our next lesson, we'll be getting into JSON representations of linked data, so that we can use document-oriented databases like MongoDB in order to search them and organize our facts into collections of documents rather than in the graph. So looking forward to that.